You're listening to the VSL Aviation Podcast. I'm your host, Seth Lake, and welcome to Episode 3. Welcome. Thanks for listening. Thanks for watching if you're on YouTube. Like I said, this is Episode 3, and we're covering the ACS. So this is the first series of podcasts that I decided to do over the Airman Certification Standards for Private Pilot. So we're doing the Private Pilot ACS, and we're on Area of Operation 5. So we've covered 1 through 4 in Episodes 1 and 2 of the podcast, if that makes sense. Hopefully it does. So if you haven't done so, go ahead and listen to Episodes 1 and 2, and you'll get caught up in the ACS where we're at right now. So we're starting up on Area of Operation 5. That's Performance and Ground Reference Maneuvers in the ACS if you're following along. I've got it pulled up on my computer screen, so if you're watching on YouTube, you can just watch it there. If you're listening on the podcast format, then you can just follow along in your version of the ACS or take notes. So Area of Operation 5 is our Performance and Ground Reference Maneuvers, and our first task is steep turns. So like we've already talked about with the ACS format, we have our knowledge item, our risk management, and our skills, and you have to demonstrate proficiency and all of the skills that are listed there in the ACS. So, skill number 1, clear the area. I can't tell you how many times that applicants have failed to do clearing turns before this maneuver. And it's part of your job as pilot in command. And it's one of the things that I'm evaluating, but it's also kind of tricky because it's a check ride environment and it's a little confusing about who the PIC is, even though we cover it in the briefing. And I tell you, as the applicant, you're the pilot in command. It's up to you to operate this plane safely. I'm here as the examiner just to give the test. So if I ask you as the pilot in command, hey, do steep turns. Part of the way to do steep turns safely is to first do a clearing turn. I'm not going to say, hey, do clearing turns and then do steep turns. I'm just going to ask for steep turns. So because it's a check ride, a lot of applicants think, okay, well, the examiner asked me to do steep turns, so I better do steep turns right now. No, do clearing turns. So slow things down. Take command of the flight. Be the pilot in command and say, well, before I do steep turns, I need to do some clearing turns. So clear the area. Establish the manufacturer's recommended airspeed. If one isn't available, don't exceed VA, which is your maneuvering speed, which makes sense. Generally, there's a lot of airplanes that don't have that established. So you need to work with your instructor in figuring out what power setting gives you a reasonable airspeed to do this maneuver at. Roll into a coordinated 360-degree steep turn with approximately 45 degrees of bank. Perform the task in the opposite direction as specified by the examiner, and then maintain an entry altitude plus or minus 100 feet, airspeed plus or minus 10 knots, bank angle plus or minus 5 degrees, and roll out on heading plus or minus 10 degrees. So this is a very specific skill set, so you need to maintain your altitude, heading, airspeed, bank, and heading. The best way, I see a lot of applicants mess up on the heading because they're kind of locked into their directional gyro or their HSI, and they're kind of turning it into an instrument maneuver. When I'm teaching this maneuver, I always make sure that my students are looking outside, and they pick a really good visual reference point outside, and they kind of drag the nose, the glare shield, kind of drag it across the horizon all the way back around to their visual reference point using the directional gyro or their HSI as a backup. But outside should be your primary reference. And if you pick a really nice big mountain or lake or maybe town center or nuclear plant like we have around here, it'll make the maneuver a lot easier. Doing it in the opposite direction, that's something that I'll pretty much always do with all of my applicants. So we're going to do it left, and then you're going to roll out and go right. It doesn't say do it immediately in private pilot standards. It just says perform the task in the opposite direction as specified. So really you'd argue that you don't even have to do it in the opposite direction, but typically we're going to do both of these turns. Okay, so let's look at just one of the knowledge areas and risk management areas. Let's say collision hazards to include aircraft and terrain as a risk management. If you're not clearing the area, you didn't verify that you're not going to collide with any other aircraft in the area. Terrain and obstacles, you could argue, well, I'm at a safe altitude, so I've verified that I'm going to clear terrain and obstacles. But if you're not doing clearing turns, you don't know if there's any traffic out there. So that would be 2 strikes, where you didn't meet the skill area and you also failed to meet one of the risk management areas of clearing the area. Knowledge, overbanking tendencies. This is a big one. We do a lot of training in Beechcraft, which do have a steep spiral tendency once you get beyond about 40 to 45 degrees angle of bank. If you're flying an aircraft that has that overbanking tendency, which most of them do to some extent have that overbanking, then you need to be aware of that. So that's something that I might ask direct questions on, or I might just kind of sample your knowledge as we're doing the maneuver with a couple of questions before or after the maneuver. That may be something that I do there. Ground reference maneuvers. This is your next one. So we're on task B, ground reference maneuvers. So we have 3 options here. We have the rectangular course, the S-turns, and the turns around a point. We're going to do these based on, if you look at the skill area, it says the evaluator must select at least one maneuver for the applicant to demonstrate. So as the examiner, I have to select at least one. We don't have to do all 3, and seldom do I make applicants do all 3. Usually we just do 2. I usually do S-turns and turns around a point. Occasionally we'll do rectangular courses just to mix things up a bit, but typically I'm going to ask for S-turns and turns around a point because honestly I think they're maybe a little more challenging. If the winds are really high, I may elect to do rectangular course just to make it not easier, but a little more reasonable, because once the wind gets above 30 knots or so, turns around a point can get really difficult. Whereas a rectangular course, I feel, is sampling the same skill set, and it's a little bit more reasonable to have a private pilot perform a rectangular course in high wind situation than a turn around a point. Don't hold me to that. I'm not signing a contract and saying that you're definitely going to have that on check ride in high winds. It's just something that I take into account as an examiner. So step 1, clear the area. Again, you want to make sure you're clearing the area. Select a suitable ground reference point, line, area as appropriate, and then plan the maneuver. Either a rectangular course, 600 to 1,000 feet, S-turn 600 to 1,000 feet, and turns around a point, 600 to 1,000 feet. This is another one where occasionally, not occasionally, I'd say more often than not, the applicant picks an altitude that's actually too high. The ACS says 600 to 1,000 feet for these maneuvers. So if you come out here, ground elevation is somewhere between 400 and 500 feet. If you say, well, I'm going to do it at 2,500 for safety, I'm like, well, that's not what the ACS says. It actually says do it at a lower altitude. So 600 to 1,000 is what we're looking for. Notice the ACS isn't saying a specific altitude. It's giving you a range. For these ground reference maneuvers, it doesn't matter if you're in 1,000 feet or at 1,000 feet or 600. Now, we do have a commercial maneuver called the 8s on pylons, and that altitude you do have to actually calculate, and you have to be at a specific altitude. But for private pilot, you don't have to be at a specific altitude, just 600 to 1,000. So the big thing that I'm evaluating here is, can you pay attention to the airplane's instruments, flying the airplane? Can you keep control of the airplane without looking at the gauges constantly? So where I see people really struggle with this is if they're really comfortable of just staring at, and not to bust students that have a lot of glass experience, but I do see this more often than not in aircraft that have big glass displays, is they tend to really focus on that synthetic vision or that big glass display, and they struggle with these ground reference maneuvers because these ground reference maneuvers hinge on your ability to look outside the aircraft at the ground and divert your attention back inside momentarily, but then still look outside. So can you fly the airplane without just being locked onto your instruments? That's really what we're evaluating here, is that ability to divide attention between control of the aircraft, avoidance of the ground, your ground track, and then also maintain your altitude plus or minus 100 feet and your airspeed plus or minus 10 knots. So those are the objective measures that we're looking at there. One of the risk management items, failure to divide attention between the airplane and aircraft control, or the ground reference and aircraft control. So that's a big one there. Collision hazards. If you're not doing clearing turns, collision hazards are a real big deal at this altitude, because at 600 to 1,000 feet, you can bet that there's some obstacles down there, especially in this neck of the woods where we have some mountains very nearby the airport that are over 1,000 feet, and the towers on top of those are well above 1,000 feet. So if you're not doing a clearing turn, you could definitely put yourself in an unsafe situation there. And again, that's a clean kill for disapproval on a check ride, is if you put us in an unsafe situation. I really don't have any wiggle room as an examiner, so don't do it. Clear the area. Make sure you do a little bit of reconnaissance of the area beforehand and know where the low-lying terrain is, maybe some good farmland, because we also don't want to be doing this over folks' houses. I don't really like doing that, especially at these altitudes. So if we can find some nice uninhibited land, sorry, that would be a great place to do these maneuvers. And then, well, for the knowledge area, effects of wind on ground track relative to the ground reference point. That's a real basic one. That's kind of what all these things are doing, is seeing if you can analyze the wind properly during the course of the maneuver to make it work out. Now, one thing that happens, and this tends to happen more at the big flight schools that have a very set syllabus, which syllabuses are great, but they have a set syllabus on how they teach it. And a lot of these flight schools will say, well, I'm going to do a wind circle before I do this maneuver, and I'm going to figure out where my wind is, and I'm going to enter on the downwind or the upwind, whatever the airplane flying handbook says. If you want to do that, that's fine, but notice that entering on a downwind isn't on the ACS. So entering in a specific way on these maneuvers, either downwind or upwind, it's not in the ACS. So technically I could ask you, hey, perform the S-turn on this heading on that road. Now really it's your responsibility to pick out the line and all that, so I'm going to let you do that, but don't get too wrapped around the axle about where the wind's coming from. The purpose of these maneuvers, if you've really mastered the aircraft, is that you can enter that turn around a point or that S-turn or that rectangular course with the wind coming from any direction. It doesn't matter, because you're going to be able to analyze that throughout the course of the maneuver and do it successfully no matter which direction the wind's coming from. All right, so we're on to navigation, pilotage, and dead reckoning. So let's, again, start out with the skills. Prepare and use a flight log. Navigate by pilotage. Navigate by means of pre-computed headings, ground speeds, elapsed times. Use the magnetic direction indicator to navigate to include turns to headings. Verify position within 3 nautical miles of flight plan route. Arrive at en route checkpoints on the initial or revised ETA, and then maintain the appropriate altitude plus or minus 200 feet and heading plus or minus 15 degrees. So, S6 is arrive at the en route checkpoints within 5 minutes. So the skill for the nav log is very specific. And notice, nowhere in there does it mention GPS. So you cannot fly or meet the ACS requirements by planning a straight line cross country from point A to point B with no points in between, because that is not pilotage. That is not dead reckoning. That is a direct to, and that's an RNAV function, which is more of an instrument maneuver than it is a private pilot maneuver. So if your cross-country plan is point A to point B and that's all that's in there, then you're wrong. I'm sorry. The ACS is very specific here. It wants you to use pilotage and dead reckoning. So what exactly does that mean? Well, pilotage and dead reckoning mean that you're using a clock and a map, and you're doing some pre-flight beforehand, and you're drawing these course lines out. You're correcting for magnetic variation, you're correcting for magnetic deviation, you're correcting for winds, and you're coming up with an estimated time in between 2 points. So when you reach point A, you're going to hack the stopwatch, and you know that in 11 minutes you should be at point B. Well, if in 10 minutes you're at point B, you got there faster than you thought, so you must have had some stuff change, probably wind speed there. That's the type of analysis that I'm looking for. And that's about the distance that I'm looking for. These waypoints need to be around 10 to 15 minutes apart. So if I ask you to plan across country from here to Destin, and you show up and you just have 3 points. You have from here to Meridian and then Destin. Those are your 3 points, and you're just going to figure it out along the way. And that's incorrect. And in fact, we're going to have to make some changes to that flight plan before we can even go out and do the check ride, because on the check ride, we're actually going to have to do this. We're going to have to navigate to the first couple of checkpoints, and you're going to see that in the subsequent tasks that are or areas of operation in Pilotage and Dead Reckoning here in your navigation section. So some of the knowledge items, a lot of this we're going to cover in the ground when we cover your nav log, but we're going to talk about magnetic compass errors. We're going to talk about selection of a route, selection of points that you can actually see from the air and identify, and then collision hazards or distractions. That's a big one, is distractions. Is one of the things that I'm evaluating on the navigation portion is your ability to read a map and navigate while still maintaining plus or minus 200 feet and 15 degrees of your heading. So you're going to be doing a lot of shuffling with the map here, and I kind of call it, when you get in the plane, you really need to build your nest. That's what we used to call it in the military, is you get in there, you build your nest, you have your flight plan out, you have your chart folded up properly. It's a lot easier with the iPad, where you can just have your iPad on your knee board and you can have the route pulled up correctly. And iPads are totally okay. That's fine. But what we're going to do to your iPad is we're going to turn off your location services, so you're not going to have your moving map, right? It's just going to be really a digital chart. So you're going to be looking at this digital chart, and the only way you know where you're at on that digital chart is using Pilotage or Dead Reckoning. So our navigation systems, that's our next one. We're going to use airborne electronic navigation systems. So they've kind of opened this up in the PTS, or from the PTS, where we had to do a VOR before. We're just need to use an airborne electronic navigation system. That could be a VOR, right? That's an airborne electric navigation system that shows the GPS. So I can use either one of those. We're going to intercept to track radial bearing as appropriate. We're going to recognize and describe waypoint passage if appropriate, recognize signal loss or interference if applicable, use communication procedures when utilizing radar services, and then maintain an appropriate altitude plus or minus 200 feet plus or minus 15 degrees. So typically I'll give this, I'll give task B in conjunction with your simulated instrument conditions. So you'll be under the foggles, and I may tell you to proceed direct to Little Rock. And what I want you, or what I'm expecting you to do, is go to the GPS and use the direct function and type in LIT appropriately, spin that into your course if appropriate, and track that course to Little Rock. In the interim, I might be simulating a radar services environment. So I might be talking to you in the same way air traffic control would be talking to you, or Little Rock approach. And so I may give you a new squawk code, I may give you some headings to fly to, some altitudes. This is a scenario-based check ride, so I'm going to try to stay inside of that scenario environment, and it's not just going to be, okay, track to this point. I'm going to give you a point in conjunction with some sort of scenario that we're kind of building in the check ride there. Some of the knowledge and risk management areas. So for risk management, failure to manage automated navigation and autoflight systems. If the airplane has an autopilot installed, I'll ask you to turn that autopilot on and make sure that you know how to use it properly, and most importantly, you know how to disconnect it if it's not doing what you want it to do. So just because it's a check ride, I think there's this misunderstanding of a check ride where, as a DPE, I want to see you fly everything manual and don't use any of the technology on board. You can't use ForeFlight, you can't use the autopilot, you can't use the GPS, because those are cheating. I totally disagree with that. Those aren't cheating. Those are important systems of the aircraft that you need to understand how to use. You need to master those parts of the aircraft and parts of the flight planning software, just like you need to master flying the aircraft, kind of the stick and rudder skills. You need to have mastery of both, not just flying the airplane stick and rudder. You need to be able to manage all those systems on the airplane. So I'm going to be definitely looking for you to be able to use those systems that are on the aircraft. And then knowledge, ground-based navigation or satellite-based navigation. know the difference. Know that, okay, this GPS is working with satellite-based navigation system versus tuning in a VOR is limited by line of sight. So if I'm trying to tune in a VOR that's 200 miles away, it's not going to work. But if I'm trying to navigate direct to a point that's 200 miles away, I can do that with GPS. So just some of those basic understandings of navigation. Diversion. All right, so again, this is going to be part of our scenario where you're going to have to, I'm going to give you some sort of scenario that's going to cause you to divert. So select a suitable destination and route for diversion. Make a reasonable estimate of heading, ground speed, arrival time, and fuel consumption. That's something that I'll ask for directly in the plane after I ask you to divert. I'll say, all right, give me a heading, time, distance, and fuel consumption to the airfield that you're deciding to divert to. Maintain appropriate altitude and heading. Update and interpret weather in flight, and then utilize flight deck displays, digital weather, aeronautical information as applicable. So in my scenario, personally, this is how I work it, is up until this point, we've been using pilotage and dead reckoning. So I haven't allowed you to use the GPS. But remember, the last task was you need to see how to use the GPS. So I need to evaluate your ability to do that. So where I do that is at the diversion. I'll say, okay, we've used pilotage and dead reckoning to get to your second point on your flight plan. Now I want you to divert to this other airfield, and I want you to do so using GPS. And so now it's easier, right? Now I can use the direct nearest function maybe, or I can use the direct to on my GPS if it's installed. If not, I might allow you to turn on location services on ForeFlight and see how you would use ForeFlight to help you make that diversion decision. Because again, these are all things that I want you, that I want to see that you know how to use in the aircraft. All right, loss procedures. Use an appropriate method to determine position. Maintain appropriate heading as necessary. Identify prominent landmarks and use navigation systems facilities to contact ATC. This can be difficult to build into a scenario, especially if you're from the local area. So I may ask it in the course of a scenario, saying, okay, ATC's lost radar contact on you, and they tell you, hey, radar contact lost, go ahead and give us a position based on a radial DME of a local VOR or approximate position in relation to another airport. So while I can't actually cause you to get lost, but I can build a scenario that would sort of use the same skill sets outlined in the skill area here of this task to make sure that you know, in case you are lost, you know the tools necessary to determine your position relative to another airport or terrain. All right, distractions, that's a big one for risk management here. All of these, where you're navigating a lot, it's a recipe for distraction. And that's one of the most important things that I'm evaluating here. And applicants that are successful are ones that slow things down, and they're not trying to do any of this fast. They're just focused on flying the airplane first and foremost. They're maintaining heading, they're maintaining airspeed, they're maintaining altitude. If they take an extra 15 minutes to figure out all these things, no problem. On the other hand, if an applicant gets all of these loss procedures and diversions done really quickly, but they fail to maintain aircraft control in a reasonable way, like heading and altitude and airspeed, that's where we'll probably be looking at a disapproval for this task. Because while you were able to, navigate the airplane correctly, and you were able to maybe find your diversion airfield and give me that information really quickly, you didn't demonstrate your ability to do that while also maintaining safety of flight and flying the airplane in the specified manner. So slow things down. Just, okay, heading, airspeed, and then I call it, taking bites. I'm focused on my heading, airspeed, altitude, and then I'll take a bite of the GPS. Maybe do a couple seconds over on the GPS, and then come back. Heading, altitude, airspeed, cross track's looking good. Okay, now over here, another 2 or 3 seconds on the GPS, or maybe a couple seconds heads down using ForeFlight. So take everything in small bites. And remember, a lot of this for the navigation, the loss stuff, you might have the foggles on as well. And I'm also seeing your ability to fly by instruments. All right, so that's loss procedures. All right, we are, let's see, that was 6. We are on 7, slow flight and stalls. This is probably the last one we cover for this episode. So we have some tasks here. Maneuvering during slow flight, that's our task A for slow flight and stalls. So number 1, clear the area. All right, and then select an entry altitude no lower than 1,500 feet for single engine and 3,000 feet for airplane multi-engine. So those are 2 safety considerations. That's a skill that you have to demonstrate. So when you're asking, hey, Mr. DPE or Mrs. DPE, what altitude should I go to? That really shouldn't be a question. You should know exactly what altitude you need to go to. You need to find an entry altitude that's going to be no lower than 1,500 feet and no lower than 3,000 feet. Establish and maintain airspeed where any further increase of angle of attack, increase in load factor, or reduction in power would result in a stall warning horn. So it talks about this in the ACS, where if momentary activations of the stall warning horn happen, that's not grounds for failure. So if in the process of trying to establish yourself at that airspeed where any further change of the status quo results in a stall warning horn, you inadvertently make that stall warning horn go off, that's fine, as long as you're recognizing and correcting from that stall warning horn and flying us at that slowest speed possible without getting a buffet or stall horn, etc. Accomplish coordinated straight and level flight, climbs, turns, descents with the airplane configured, specified by the evaluator without a stall warning horn, and maintain specified heading altitude, or altitude plus or minus 100 feet, 10 degrees of heading, plus 10 minus 0 knots for the airspeed, and plus or minus 10 degrees of bank. So I may have you turn to headings, I may have you climb. We're probably just going to start out with straight and level. And that's honestly where I see people struggle the most, is they get configured for slow flight and we start to descend. Because once you get on that back side of the power curve, you're actually going to need more power the slower you go to maintain that altitude and airspeed. And if you don't do that, you're going to start to descend. And remember, our skill says right here, plus or minus 100 feet from the altitude that we specify as the examiners. All right, power off stall. Oh, before we go there, let's look at a couple of we only have one knowledge. So aerodynamics associated with slow flight. I wonder which knowledge area the examiner is going to pick on here. There's only one to pick from, so you know exactly what you're going to do. The risk management areas. Inadvertent slow flight and flight with a stall warning, which could lead to loss of control. Range and limitations of stall warning indicators. Failure to maintain coordinated flight. Those are all examples of risk management areas there. And make sure, again, collision hazards, you're doing clearing turns. Do clearing turns. All right, power off stall. The skill set here is a little bit longer than slow flight. So first, clear the area. Choose an altitude. Sound familiar? Configure the airplane. Establish a stabilized descent. So in the Air Force, we call power off stalls. We call all of these stalls traffic pattern stalls, which I kind of wish the FAA would do that because it makes more sense. Is what we're doing is we're simulating stalls that could potentially happen in the traffic pattern, and a power off stall is a landing configuration stall or a base to final stall. That's another thing that we could refer to the power off stall at. So that's what we're configuring the airplane for landing. In the scenario in the check ride that I'm going to use is we're going to configure the airplane for landing. We're going to establish a descent, a 500 foot a minute descent usually, transitioning to a landing attitude, maintain heading, and then I may specify a bank. So I may specify a bank not to exceed 20 degrees, plus or minus 10 degrees if in turning flight. So I often give a turning stall where we're on a base to final is what we're simulating. So we're configured gear down, flaps approach speed, 500 foot a minute descent, and I'll say, okay, give me a nice 20 degree bank turn to the south. And while in that turn, I want you to reduce power to idle and hold the nose up and recover at the first indication of stall. So acknowledge the cues of impending stall and then promptly recover after a full stall occurs. After a full stall occurs, not just the indication. Execute a stall recovery in accordance with POH. Configure the airplane as recommended to accelerate VX, VY, and then return to the altitude and heading airspeed specified by the evaluator. So we might do a couple series of these where you recover at the first indication, and I'll have you recover at the full stall as well. So I want to feel that full stall break over. So not just first indication, but the actual buffet, and then you'll feel the nose drop. Then I want you to recover. All right, power on stalls. Again, clear the area. Altitudes sound familiar from what we've been doing. We're going to establish takeoff, departure, cruise configuration as specified. So we have takeoff, departure, and cruise. Depending on what kind of airplane we're doing this in, will depend on which of those configurations I have you do as an examiner. In high-performance airplanes, typically I'll have you configure for a cruise configuration. And the reason is, in the ACS, it talks about using a reduced power setting for power on stalls. We don't want to use full power because that would put us at a severe nose-high attitude in order to induce the stall. So what I'll typically do is kind of a flight level change stall, where maybe we're simulating you're cruising up at 10,000 feet, and ATC asks you to climb to 12,000 feet, and you just pick the nose up a little too high, and you don't add power. So we're at like maybe a 50% power setting. You pick the nose up about 15 degrees nose high, and you hold it there until you get the impending stall. So that's what I'm going to have you do. Set power as a side, no less than 65% power. Sorry, I said 50% earlier, 65%. Transition smoothly from takeoff departure attitude to the pitch attitude that will induce a stall. Maintain specified heading, 10 degrees if in straight flight, and then bank not to exceed 20 degrees if in turning flight. Acknowledge impending stall and recover after a full stall. Execute stall recovery. Configure the airplane to climb out at VXBY, and then return to the heading altitude specified by the evaluator. So, sounds pretty similar to the power off stall as far as the recovery goes, the safety considerations, and whether or not you can do it in a turn. All that's fair game in the power on stall. Now, let's talk about some of the risk management areas. We've got improper stall recovery procedures, secondary stalls, accelerated stalls, elevator trim, cross-controlled stalls. Those are all things, we're actually going to cover those in the CFI check ride, but in private pilot, it's just an area that you need to have knowledge on. Sometimes the power on stall is not uncommon to get in a small accelerated stall or secondary stall because the recovery is a little too aggressive. That's really common. And again, a momentary deviation from standard, as long as you recognize and recover, that's fine. Now, if you're continuing to hold it in that secondary stall, then we might be looking at an unsatisfactory result. But as long as you recognize, oops, pulled a little too hard there, let me reduce some of that back pressure and climb away safely, then we're good to go. Some of the knowledge areas, the aerodynamics involved with this, the stall characteristics of your airplane, and then the factors and situations that might lead to a power on stall. All right, spin awareness. So the goal here is to make sure that you understand where spins could occur, how they could occur, the aerodynamics, what causes a spin, and spin recovery procedures. Those are the knowledge items that I'm going to ask. And typically I'll ask those in the plane during the stall, saying, okay, what if, when we accomplish that stall, the left wing drops severely and you experience the airplane kind of going inverted? It feels almost out of control and starts turning rapidly to the left. What would you do? Because we're not going to actually do spins on this check ride, because if you see the skill, it says intentionally left blank. So we're not going to do spins on your private pilot check ride. We're going to talk about them, and I'm going to expect you to know how to recover from them, but we're not going to complete them. So this item is really all knowledge and risk-based items. All right, basic instrument maneuvers. Let's go ahead and cover these real quick. I promise this is Area 7, and then we'll do one more episode on the private pilot. It'll be great. So we're at our last skill set we're going to talk about here, which is our basic instrument maneuvers. We've already talked about these a little bit. So straight and level flight. Maintain straight and level flight using a proper cross-check. Maintain altitude plus or minus 200 feet, heading plus or minus 20, airspeed plus or minus 10 degrees. Again, I'm going to incorporate the straight and level flight in with one of the navigation parts of the check ride. So this is going to happen early on in the check ride. The first thing we're going to do is take off and depart on your cross-country plan. The second or third thing that we're going to do is put the foggles on and start your simulated instrument maneuvers. So Understand spatial disorientation. That's one of the risk management items I like to ask about. And then the flight instruments related to maybe correlation of pitch and bank instruments, kind of that control and performance theory of flying instruments. You're not an instrument pilot yet, and this isn't an instrument check ride, so I don't expect you to go in depth on that, but I expect you to have some sort of understanding that, all right, if I set this power setting, I'm expecting to set the nose to this pitch attitude, and that's going to result in a specific airspeed or performance. All right, constant airspeed climbs. So transition to climb, pitch, attitude, power setting on an assigned heading using instrument cross-check, coordinated flight, climb at a constant airspeed to a specified altitude in straight flight and turns, and level off at the altitude plus or minus 200 feet, plus or minus 20 degrees, plus or minus 10 knots. So again, this is going to be some sort of scenario where you're talking to ATC, you're in a simulated radar environment, and ATC gives you a turn to a specified heading and a climb or descent to a specified altitude. And you're going to do that while we're in the foggles. So again, kind of the same knowledge and risk management areas as straight and level. Maybe talk about spatial disorientation a little bit more. I may even try to induce it, saying, well, what if you're trying to sneak a look outside the window to see if you can see anything, which is real common, especially for somebody that's not instrument rated, is they get a glimpse of the ground and their head turns to go look at the ground that they saw outside. Well, that head movement, that rapid head movement, is a great way to induce spatial disorientation. So we might have a discussion about that. Constant airspeed descents, very similar to constant airspeed climbs. It's just the opposite. We're descending. That's how descents work. Who knew? So we're going to transition to a descent pitch attitude using proper cross-check, descend at a constant airspeed, straight or turns, plus or minus 200 feet, plus or minus 20 degrees, plus or minus 10 knots, and then all the same knowledge items that we've been talking about here. Turns to a heading. So turns to a heading, plus or minus 200 feet, standard rate, roll out on the assigned heading, plus or minus 10 knots, plus or minus 10 degrees of heading. Again, all three of these things that we talked about are for straight and level, climbs, descents, and turns to a heading. It's not like each of these are going to happen in a vacuum. They're going to be part of a whole scenario. So you're going to be in a simulated radar environment, getting vectored around, and we will accomplish all four of these instrument turns that we've talked about. Recovery from unusual flight attitudes. This is something that I really think is very important, is flying inadvertently, so from VMC conditions into IMC conditions. Doing that inadvertently is a very big mistake that has killed a lot of pilots. And it's done so because they either, first of all, they put themselves in that position, which is bad enough, but then they didn't have the skill set to maintain their composure, maintain aircraft control, and recover the aircraft. They got spatially disoriented, they panicked, and they recovered improperly or failed to recover at all. These crashes happen every year, multiple times a year, unfortunately. So having the ability to recover from an unusual attitude is a really important skill set for any pilot. But especially private pilots that don't yet have the skills needed to fly in instrument conditions. So the only time you're going to find yourself in instrument conditions is going to be inadvertently. And more than likely, there's going to be some degree of spatial disorientation, felt with going into the clouds inadvertently. So recognize an unusual flight attitude, perform the correct, coordinated, and smooth flight control application to resolve the unusual pitch and bank attitudes while staying within the airplane's limitations and flight parameters. So if the nose down and we're accelerating, I expect the power to come back and roll wings level smoothly and pull the nose up smoothly. Don't panic and be all herky-jerky on the controls. That's a really good way to over-G the airplane, especially when we're fast. If we're nose high, pushing the nose over, getting full power in, those are really important that I see you do that so we don't approach that stall, depart from controlled flight, and then we've just made a bad situation even worse by entering a stall or even worse, a spin, when all that we really needed to do is add power and relax back pressure, push the nose over. There's different ways that I will get you in unusual attitudes. Every examiner is probably a little different on how they do it. Generally, it involves you closing your eyes. I may have you close your eyes and fly the airplane, and we may just kind of make a little joke about it of, hey, we're going to see how you fly the airplane with your eyes closed, and I'll have you fly the airplane, and I will totally lie to you. I'll tell you to turn left or right, and say, hey, you're flying straight and level, great, and have you open your eyes, and you're in like this steep right-hand turn descending, and then have you recover from that. All right, radio communications. Again, this is going to be evaluated while you're doing the rest of the maneuvers. So while you're doing your instrument work or your diversion, I'm going to be talking to you like ATC would be talking to you. I may give you a scenario where I want you to look up the frequency for Little Rock approach or the nearest center frequency, comply with ATC instructions, maintain altitude plus or minus 200, heading plus or minus 20, and airspeed plus or minus 10. All right, we made it through 7. We're to emergency operations. We're going to come back next episode and start talking about emergency operations. And that should be our last episode in the Private Pilot series on the ACS. So I really appreciate you watching, appreciate you listening, and tune in next time for the VSL Aviation Podcast. Thanks.